Now let us consider this question. A line AB 90 mm long is inclined at 30 degree to HP. Its end A is 12 mm above HP and 20 mm in front of VP. Its front view measures 65 mm. Draw the top view of AB and measure its length, and also determine its inclination with HP. So first, initially let us write which all data are given in the question. So in this particular question, you are provided with the true length of the line, is it? So true length of the line, it is given as 90 mm. True length of the line, it is given as 90 mm. Now it is providing the inclination also. It is inclined 30 degree with respect to HP. So 30 degree with respect to HP means the value of theta, the actual inclination with respect to HP, it is 30 degree. So that value is also given. Then its end A is 12 mm above HP and 20 mm in front of VP. That is, the coordinates of point A is given. So A is, it is 12 mm above HP, 12 mm above HP, and it is 20 mm in front of VP. Okay, so 12 mm above HP and in front of VP it is 20 mm. So again, two more data are given. Then its front view measures 65 mm. Okay, the length of the front view, that is elevation length. Elevation length is given. So the length of the elevation, it is 65 mm. So these are the data that are given in the question. True length, theta, coordinates of A, then the elevation length. Is it? So totally 5 data are given, and you are asked to draw the top view of AB and measure its length. So you have to draw the top view of the line and also determine its inclination with respect to VP. So you have to find out the top views, you have to find out the planned length. So this is one data that is required. Then you have to find out the inclination with respect to VP. That is, you have to find out the value of phi. So phi is the value. So you have to find out what is planned length and what is the value of phi, that is inclination with respect to VP. So our first step is you have to draw the XY line. You have to draw the XY line. And our second step is mark the coordinates of point A. A is 12 mm above HP and 20 mm in front of VP. So we shall draw the coordinates of point A. So A is 12 mm above HP and A is 20 mm in front of VP, is it? So we shall mark the coordinates. So let us mark this point as A dash. So this point is A dash. Then A is 20 mm in front of VP also. A is 20 mm in front of VP. So we'll be marking it below the XY line, is it? We'll be marking it below the XY line, 20 mm. So this will be point A. And we shall draw two reference lines, is it? That is our other. So we'll be drawing a reference line through A dash, which is known as locus of A dash, and we'll be drawing another reference line through point A, which is known as locus of A. So we shall draw two reference line. We shall draw two reference line. So using your roller scale, you draw a thin line, type B line, then one more thin line through point A. This is locus of A. So let us write it as locus of A and locus of A dash. So this is locus of A and this is locus of A dash. Locus of A dash. Now, so we have applied two data, is it? That is the coordinates of A and A, that is 12 mm above HP and 20 mm in front of VP. So in this question, true length of the line is given and the inclination of the line is also given with respect to the horizontal plane. So definitely we shall apply these two data. So true length is given and the inclination of the line with respect to the horizontal plane is given. So when you are observing from the front, if you are treating this line initially parallel to VP, you will be able to see the true length and true inclination in the front view, and thereafter you can draw the top view of this line also, is it? So let us do those steps. So initially we are applying these two data. Okay, So we shall draw the front view with a true length of 90 mm and with an inclination of 30 degrees. So using your protractor, let us mark an angle of 30 degrees. Now we shall draw a true length line of 90 mm. Please remember that you have to draw it using thin lines, okay, type B lines, because this is not our actual line. So you are drawing it as a thin line. So at the end you have to write it as B1 dash, because this is not our actual line and this is having true length, is it? So this is a true length line. And this inclination is 30 degrees. This inclination is 30 degree. Now we shall mark this dimension also here. So this is 30 degree inclination with respect to the horizontal plane. And we shall draw the corresponding top view of this line also. So how to draw the top view? You draw a perpendicular. You drop a perpendicular from B1 dash up to the locus of A. Then you will be getting a meeting point on the locus of A. So please remember that when you are dropping this perpendicular must be perpendicular to the xy line also. So you are dropping a perpendicular here, just dropping it, and you are getting the top view. So let us mark it as point B1, and let us draw another thin line here connecting B1 and A. So this will be the length of the top view, is it? So this is, again we shall mark it as plan length. We shall mark it as plan length. And we shall do some more steps related to this front view and top view. This is not the final front view and final top view. So the next step is we will be drawing a locus line along B1 dash. Okay, we shall draw a locus line along B1 dash. So parallel to the xy line, we shall just roll our roller scale, and we will be drawing a locus line here. So this is locus of B dash. This line is known as locus of B dash, is it? This is locus of B dash. And we shall draw an arc in the top view also. So that is locus of B. So using your compass, taking A as center and A B1 as a radius, we will be drawing an arc in the top view. So this is also locus of B. Locus of B. So we applied true length theta, the coordinates, and now the last data that is to be applied is the elevation length. It is the elevation length. Length of the front view is given in this particular problem. So how to apply this length of the front view? In which all cases or where we can draw this front view? You just consider the previous question. So in this diagram, in this particular diagram, so we are having, this is an elevation length line, is it? This is having elevation length. So elevation length, it is between A dash and B dash, is it? So B dash will be always along the xy, along the locus line. And here also we are having an elevation length. Okay, so this elevation length, it is along the locus of A dash. So as the elevation length is given in this particular problem as 65, we are able to draw the front view directly, because we know that front view will be between locus of A dash and locus of B dash, is it? Definitely A dash will be here. We have fixed point A here, and B dash will be along this line. Okay, so only thing that we have to know is what is the length connecting A dash and B dash. It is already given in the question as 65, is it? So we shall draw the front view directly. So how to draw the front view directly? You take 65 mm in compass. Take a measurement of 65 mm in the compass, and so you are taking a measurement of 65 mm in compass, and with A dash as center, you cut an arc on the locus of B dash, and this point will be B dash. Okay, this point is B dash. Now connecting A dash and B dash, will be getting the actual front view, which is having elevation length, is it? So this is elevation length, which is already given in the question, and you are drawing this elevation length by cutting an arc, is it? So we have just marked cut an arc which is having a radius of 65 mm. So in order to just indicate it, we shall draw a dimension line here. So this is a dimension line. So this is R65, and after drawing the elevation length, we shall add the elevation length to one more location, is it? So if you compare this diagram, so here we are having an elevation length, here also we have got an elevation length. So this elevation length is actually on the locus of A dash. So here also we have got locus of A dash. Okay, so we shall mark this also. So this is A dash, B2 dash, is it? So here also we have got an elevation length in between A dash and B2 dash, is it? So we shall draw the same elevation length here also in the, so already in our compass this is 65. We shall just rotate this arc up to the locus of A dash, is it? So we shall just rotate it up to the locus of A dash, and this point, this meeting point, this is B2 dash, is it? This point is B2 dash. So let us mark it as B2 dash. This is again elevation length, and this is again a thin line. Already there is a thin line. Now the next step is, so what we require is you have to draw the top view of AB, measure its length, and also determine the inclination with respect to VP, is it? So how to draw the top view? You have to obtain AB, is it? A dash, B dash is already there in our diagram. So how to obtain AB, which is the actual top view? So please compare it with this diagram. So here we are having A dash, B2 dash, is it? Here you are having A dash, B2 dash, and there are actually many ways in which we can do this particular problem. There are many ways in which we can approach this particular problem. So you just make a comparison here. So this is point B. If you are able to locate point B, you will be able to draw AB, which is our actual top view, in this diagram also. So here we are having locus of B. Here we are having locus of B. So through this point B, actually three lines are passing, is it? One is locus of B. This is a locus line. Another one is this locus R, which is again locus of B. And the third one is this line, which is joining B dash and B, is it? So in our diagram, already we are having this locus arc. If we are dropping a perpendicular from B dash to this locus arc, the meeting point of this perpendicular and this locus arc, please observe here, the meeting point of this perpendicular and this locus arc, this is point B itself, is it? This is point B itself. So by this method also you can find out point B. So let us do the same in our problem. We shall drop a perpendicular. So you please make sure that it is exactly perpendicular to the XY line. So drop a perpendicular from B dash. So here we are having the meeting point. So this meeting point is point B, is it? This meeting point is point B. Now connecting A and B, you will be getting the actual top view. Connecting A and B, you will be getting the actual top view. So this is having plan length. Okay, this is having plan length. So you obtained the actual top view. So you have to draw the top view and measure its length. We shall measure the length later. Now you have to find out, you have to determine the inclination of the line with respect to VP. So if you have to find out the inclination of the line with respect to VP, just consider this diagram. So in this diagram, we are having a true length line. Okay, we are having a true length line. Only with this true length line, this angle will be visible. This angle can be found out. So in the previous problem, it was 45 degree. The value of phi, that is inclination with respect to VP, was 45 degrees. So how to find the value of phi, that is the actual inclination with respect to VP here. So how we can find it out? So this is how we can do it. There are many methods by which we can find out the value of phi. So let us try out this method. So along point B, we have got a locus line here, is it? This is the locus of B. We shall recreate this locus of B onto this problem. Okay, so locus of B is actually a line that is parallel to the xy line, parallel to the xy line. So parallel to the xy line, let us draw a straight line here. So parallel to the xy line, you keep your roller scale on the xy, you just roll it up to the point B, then you draw a chain line here. So this is presently locus of B, is it? Locus of B. Now it is onto this locus line of B we are having point B2, is it? So this is B2 connecting A and B2. This is actually a true length line, so if you are able to draw this A B2 line in our problem, we'll be able to find out this actual inclination, which is phi. So how to draw this true length line? Already the true length is given in our question. So in our question, the true length is given as 90 mm, is it? In our question, the true length is given as 90 mm. So take 90 mm in the compass. So take 90 mm in the compass. So 90 mm. And with A dash as center, you cut an arc on this locus line, and this meeting point is point B2. So this meeting point is point B2. Now you join A and B2 in order to get the true length line. Join A and B2. This is also a type B line. So this is having true length. This is having true length. And along with this true length line, we'll be getting angle phi. Okay, so if you measure this angle will be phi. This angle will be phi. So let us measure what is this angle using our protractor. So the value of phi is approximately some 42 or 43. I'm getting it as, it is nearly 42 or 43. So the value that I'm getting, let me write it as 43. So the value of theta, sorry, the value of phi. So the value of phi, I'm getting it as 43 degrees. And when you are measuring, you may be getting it as either as maybe you are getting it as 44, or you may be getting it as 42. So whatever value you are getting, you are write it as such. Okay. So when I refer to the textbook, the actual value that is given in the textbook is 44 degrees. So you can have a variation of 1 degree. That is, you can get it even as 45 or 43 is also acceptable. But beyond this limit, it is not acceptable. Okay, so I'm getting it as 43. The actual value that is given in the text is 44. So there is only a variation of 1 degree, which is acceptable. Okay, now you have to measure the length of the top view, length of the plan, is it? So what is the length of the top view? What will be the length of the top view? You measure the length of the top view. So measure it. It is approximately 79. Okay, it is approximately 79 mm. Plan length 79. Okay, so you have to write it inside a box. So as per the textbook, the value is 78. The plan length is obtained as 78. A variation of 1 mm is allowed. You can get it as 77, or you can get it as 79 also. So that is okay. So this is the final solution. You have drawn the projection, you have drawn the top view, you have obtained the value of phi. Okay, you have obtained the value of phi. So please remember that you have to write it separately onto the right hand side. Now we shall do the dimensioning process of this diagram. Dimensioning. So all the dimensions which were given in the question, we have marked it here. That is tool length 90, angle 30, then coordinates of a 12 mm above HP and 20 mm in front of VP. We have got one more dimension, that is the elevation length. So we have to mark it, already I have marked it here, that is R65. So with this, this problem is complete. So please remember that you have to write the values that are asked in the question separately inside a box.